Okay guys, so in this video let's talk about our important data structures called as stack. Okay, so what do you mean by stack? A stack is something which is a linear data structure, of course. Linear data structures. Okay, linear data structure. And you can implement stack in C program using two ways. Okay, you can implement in C using arrays or linked lists. Okay, so stack can be implemented in two ways. Either you can go for arrays or linked lists. Okay, so there are two ways to implement stack. Okay, there is no separate data type called as stack in your C program. In C program you have arrays, right? So using arrays you can implement stacks. Okay, but you have certain conditions in stack, guys, and you have to follow that whenever you implement stack. Okay, so first of all, what is a stack? Okay, what makes it unique? Let's discuss about that. Okay, so a stack is something. Okay, let me consider this is a stack. Okay, this is a stack, and which is shielded at one end. Okay, so this is a basically shielded, which means you can't insert any element, or you can't take any element from this end. Okay, this is completely shielded. Okay, but from let's say this is my stack. Okay, this is basically an array kind of structure. A stack, you can insert element only from one end and you can delete from only one end. Okay, what I mean is this end is open, this end is open, so that you can insert elements and delete elements if you want, and this end is completely shielded so that you can't do anything from this end. Okay, so you can insert and delete elements only from one end, and that is a main characteristic of using stack. Okay, so you can insert and delete from only one end. Okay, so the insertion operation is called as push. Okay, so this is a very important word, guys. You should not say insert into stack, you should say push. Okay, whenever you want to say I want to push 5 into the stack, you have to say push 5. Okay, so push denotes that we are inserting something to the stack, into the stack. Okay, and removing something is called as pop. Okay, removing something is called as pop, and pop is something which means that we are removing something, we are removing a single element from the stack. Okay, so you always have to use these two keywords. Okay, you should not use insert or delete, and that is wrong whenever you use stack data structure. Push means insert and pop means deleting or removing a single element. Okay, single element. Whenever you call this pop function, that should delete a single element. Okay, I'm sorry. Okay, and both these are performed from only one end. Okay, let's say in the stack let's say I wanna, so what are the addresses I have? So let me say I have 4 addresses actually, which means that I can store 4 elements, right? Let me say this is 0, this is 1, this is 2, and this is 3. I'm just naming the address name. Okay, so this is this will store 0th element, first element, second element, and third element. Okay guys, so okay, so let me insert let me say push 5. That's my command. Okay, push 5. So I just want to insert 5. So through this area I can insert 5. So I am inserting 5 here, and so let me name the stack as variable A. Okay, so this stack is called by the name variable A. You know this, right? If you know the basics of C programming, you know what are the names of variables, and you know the conventions to name any variable. Okay, so this stack is named as A. Let's assume that. Okay, so with having that assumption, then this is called as A of 0, this is called as A of 1, this is called as A of 2, this is called as A of 3. Just an array. Okay, we are implementing stacks using arrays only. Okay, so I am pushing 5, which means that I have 5 stored in A of 0. Okay, so let me push one more element. Say I am pushing 6. Okay, so I am pushing 6 here. Okay, so 6 is pushed. I am pushing 7 to the stack, so I will be having 7 here. Okay, so also, okay, these are my pushing operations. Okay, so these are my pushing operations. Let me say I want to pop an element from the stack. Okay, so what do you mean by pop? Oh, understand that whenever I say push, push 7, push 6. You need an element, okay? If you want to push something, you should mention what which is the element you want to push and what are the elements that you want to push. You have to mention the element also, okay? I couldn't simply say push, okay? I have to say push 10, push 20, push 30, or push 45, push A, push B, whatever it is, but I have to mention an element, right? Then only I can my stack will push into that, okay? But if I want to pop something, there is no need to mention any element. Pop means always remove the first element, okay? Always remove the first element. That is what we mean by pop. If you call pop, then the first element will be removed. But okay, again, this is a question: how do you identify the first element? Okay, how do you identify the first element? Okay, so that is a special pointer variable called as top. Okay, so what do you mean by top? And okay, let's be curious. Okay, what do you mean by top? Okay, so let's explain that in the next video. And in this video we are covering the main basic operations of stack, which is nothing but push and pop. And be curious about it. Okay, think what is top. Okay, what does it do? It's self-descriptive. By the word itself you can understand, and this is very important keyword in stack. Okay, so whenever you talk about stack, there are three keywords which are very important. One is push, another one is pop, and the major one is top. Okay, without you can't expect a stack without a top. Okay, this top is something which is very important. I'll explain about that in the next video. Thank you. Okay guys, I promised you that I will explain about top in this video, so I hope you might have guessed about some some facts on top. Okay, so let me explain what is top. Okay, so consider I have a stack here. So let me say I have 4 locations. Okay, I have so let me say I have 5 locations. Top is a variable. Top is nothing but a variable, guys, which will have a value whose initial value is always -1. Okay, the initial value of top is always -1. Okay, so this is very important. The initial value of top is always -1. Okay, so what do you mean by top? Okay, so whenever the top is -1, it means that the stack is empty. Okay, whenever the top is -1, it means that the stack is empty, which means that it does not have any elements in it. That's the meaning of having top equals to -1. Okay, so I'll say let me insert 10 into the stack, which means that I have to increment the top by 1. Okay, so I'll say top equal to 0, which is pointing to this element 10. Okay, so now my top is no longer -1. I'll just erase this because my stack has only one element, and my top variable, which has a value 0, which points to 10. Okay, actually don't confuse yourself with the pointer concept in C. This is not like that. This is our understanding. Whenever I say top, I mean that whenever I say top, I mean that it keeps track of the top element of the stack. Okay, so you have only one element here, guys, so that's the top element, right? So I'll say I'll insert one more element, say 11. Okay, then my top will point to that element because that is the top element. Okay, topest element in this stack, right? In this overall stack, that is the topest element. But what is the value of top? Top is now 1. Okay, you have to increment the top whenever you are pushing something. Okay, here the top is 0. Here if I have one more element, okay, say 12, then these two will not work. Now this is these are not top variables. Okay, top points to this, and it will have a value 2. Okay, so values are 0, 1, 2, 3, 4. You know that, right? It starts from 0. These are nothing but indexes or indices. Okay, so these are like page numbers, guys, and in these pages you have certain values. Say for an example, in page number 0 you have 10, in page number 1 you have 11, in page number 2, like that. Okay, so these are the values of top. Okay, these are the possible values of top variable. Fine. So what do you mean by top? Top is nothing but a variable which keeps track of the top element, because so this is the top element, so top points to here, so which has a value 2. Okay, so this is the concept here which I wanted to insist. Okay, So always you can insert like this only. Okay, fine. And another very important concept is, so always have this top variable. Without top, stack is impossible. So okay, it keeps track of the top element. Fine. Okay, one more thing I want to insist here is, okay, these are another characteristics of stack. Whenever you know, insert element and delete element, you can do that in the only one side. Okay, only one side of the stack. And you know, you can do it in an orderly manner. Okay, you can't you know, delete randomly. Let's say I want to delete 11, it's not possible. Okay, first you have to delete 12, then only you can delete 11. Okay, in this order, only in this order you can proceed, because there is no connection. Understand that all the ends are shielded. Okay, this is shielded, this is shielded, and this also is shielded. Okay, you got only one open end, from that you can delete. Then how do you delete? You have to delete 12 first, then only you can delete 11. Okay, say for an example, I want to delete 10. How can I delete 10? You have to delete 12 first, then you have to delete 11. After that you have to delete 10. Okay, directly you can't delete 10. That's the idea here. So you can't access or retrieve an element randomly. Okay, whenever you wanted to do that, I'm sorry, I think that's a technical glitch. So whenever you want to do that, if you want to access or access an, okay, let me stick with this, access an element. Okay, you have to pop all the top elements. Okay, you have to make that particular element as the top element, then only you can access. Okay, let me repeat it again. Let me say this is my stack and I am having 10, 11 and 12. So my top points to this. Okay, so my top is 2. Okay, if there is no element, then the top variable is points to nothing, and top will have the value -1. I told you that. But here I have 3 elements, so top will point to you know, top will point to 12. Okay, so it has a value 2 because it starts from 0. Okay, you may be confusing that top should be having 3, no, because it's third element, but you know, it starts from 0, the index, so top will have the value 2. Fine. So here if I want to access 10, then you have to delete 12, 11 and so on. So fine. So this is another characteristic of stack. By this, what do you mean? That you have a lot of applications in regard to stacks in the real life also, right? So